Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. If you are new here, kindly share, like, comment, subscribe for more interesting videos and updates. Again, do well or make sure to press or click on the bell button or the subscription button to receive all updates concerning calculus. That is the integral calculus and the differential calculus. We've already set the ball rolling under logarithmic differentiation. In other words, how to differentiate simple logarithm functions, logarithm functions. For example, when you have a natural log of a function u, okay, so u is a function, and when you find the derivative of this function, this gives the differential of the function u, then all over the function u. So, for example, when you have log of the expression 5x plus, let's say 6, and you have been told to differentiate this is very trivial, and I have treated this into details under logarithmic differentiation. So this is what we call the natural logarithm functions, okay? So the ones without the basis, okay, those are the normal ones. But in this tutorial or in this session, we are going to consider logarithmic differentiation or logarithm functions involving what? Basis. Alright, so I think one of the subscribers in the comment section, and I think the person is a lady, and she asked, is it possible for us to differentiate logarithm involving basis? And the answer is what? Is yes. It is a very big yes. Alright, so those logarithms, we call them regular logarithm functions or regular log functions, okay? So those are the logarithms. For recap purposes, so what is the normal way of doing this? We say, let's differentiate u with respect to x. So I'll have what? U prime, okay? That is the differential of u, which is equal to, when you differentiate 5x, you have what? 5. And when you differentiate a constant, you simply get what? 0, right? Good. And we know, so this is the original function, and this is what? The differential of the function. So this becomes log of the expression, that's 5x plus 6. Because we are taking the derivative, okay, of this whole function, we have u prime. And what is u prime? U prime is simply 5, then all over the function itself, okay, which is 5x plus what? Plus 6. As simple as that. Another example is where you have, that's the natural log of, let's say, x squared plus 2x plus, let's say, 100. And this is very simple, right? So if you want to take the derivative of the whole function, I have d over dx of the natural log of x squared plus 2x plus 100 equals the differential of u, which is this. So x squared, using the power rule, it's what? We are going to get 2x plus. When you differentiate 2x, we have what? We have 2. When you differentiate a constant, we have what? 0. Then all over the function that is not differentiated. So I have what? X squared plus 2x plus what? 100. As simple as that. Viewers, you can factorize, okay? You can factorize over here and you still arrive at the same answer. So let us consider the regular logarithm functions, okay? Yes. So what do we mean by that? So this, you have a logarithm involving what? Bases, right? Alright. So this is the norm. Let's say if you have thus the derivative of you have log to a certain base of say a, then of, let's say, a function of say u, all right, this way. So this is equal to, we go by the normal norm, u differential, then all over the function u, then multiplying the natural log, okay? So we have length of a. So we are going to differentiate the function u, which is the u differential, and u is the original function or the function in question. And this a simply represents what? The base. This one, the logarithm base, and that is all. Alright? Also, when we have the derivative of this, they have length or the natural log of e this way, okay, then of u. This is the same as, so you have u differential, then all over your u, okay, then have times the natural log of what? That's length to the base e this way. But we know that this gives us what? 1, right? So when we substitute this into this, we will have what? U differential over what? Over u then times what? Times the 1, which is equal to u differential over u. So viewers, this is the reason why when you differentiate this, we have what? U prime all over what? Over u. Oh, there's a base here, which is what? Which is e. You get it that way? As simple as that. So in other words, when you are giving logarithm functions with respect to a certain base, this way it takes what? This form. Without the base, it also takes what? This form, which is very, very trivial. So viewers, let us consider these questions in order to appreciate logarithm derivatives, okay, or logarithm differentiation of the regular, of logarithm regular functions, okay. So find the derivative of the following. We have log to the base 2 of the expression 5x plus 6. So we have log to the base 2. When you want to take the derivative of this with respect to x of any logarithm function with respect to a certain base of say a, then you have u as a function, u then the natural log of what? Of a, where a is what? Is your base. So when you have this, so I can say that then log to the base 2 of 5x plus 6. What can we deduce from here? You can say that u is equal to what? This expression. So we have 5x plus 6. So what will be u differential? U differential will be the derivative of the whole function with respect to x. So when you differentiate 5x, we have 5. When you differentiate the constant, we have 0. Good. And what is our a? Our a, remember, a is what? Is the base, which is what? Which is your 2. As simple as that. So your final answer will be u differential. What is u differential? U differential equals 5. Then all over u, what is your u? U is this expression. 5x plus what? Plus 6. Then times, that's times the natural log of a. And what is a? A is what? Is 2. So viewers, this is the end of the question for the first one. Yes, we have log the base 2 of 5x plus 6. This way, as simple as that. So let us consider the second question. So for the second question, so viewers, let us consider the second question. So the second question, we have natural log or log to the base 5 of x exponent 6 plus 4. You already know what to do, right? So what shows that I'm differentiating? Or what shows I'm taking the derivative of this function? By including what? D over dx. Then I have what? Of log to the base 5 of x to the power 6 plus 4 this way is equal to u differential. In other words, I'm supposed to differentiate this, right? So I have 6x to the power 5 using the power rule. Then all over, do I know u? This is u. And u is simply this expression. So I have x to the power 6 plus 4. Then I have this multiplying what? That's log to the base. That's log of a. Okay, what is a? My a is 5. Okay, viewers, this is not a base. This is log 5. Okay, yes. So viewers, this is simply the end of this question. And the last question reads: you should differentiate this. So I have d dx of 10 log to the base 4 of 2x this way, which is the same as u differential. Do you know u differential? Yeah, it's this. It's simply this, right? So I have, if you differentiate 2x, we have 2. Then all over, what do we have? This is 2x represents our u. That's the original function. So I have it to be 2x, then times, you have log of 4, because this is the base, okay? So you have log 4 this way. But remember, what's happening here? 10 multiplies what? The whole function. So that means this whole expression will be multiplied by 10. That's what it means basically. So therefore, we can say that 2 cancels 2 over here. So we have 10 all over x, then log of 4. As simple as that. And this is the same as, you can bring this over here, okay? This is just simple algebra. Viewers, this is the end of the tutorials. Do well to subscribe, share, comment for more interesting videos and updates. So far as Tindanious science and math is concerned, Charlie, in fact, we are going to explore. Bye.